Hello and welcome students. This is lecture number 19 of indefinite integration. In this lecture, we shall be solving few more problems on integration by parts so that you get more practice on integration by parts. As we know, integration by parts is one of the most important type of integration problems so far as the exams are concerned. So let's begin with one problem here. It is the book which I'm using. In that it is exercise, exercise 3.3, and it is first and first tenth. So I have to integrate e raised to 2x into cos of 3x dx. So the first step, as you all know, we will write this integral to be I. Okay, so this is one very important type of problem, e raised to x into cos 3x dx. Now, this integrand, I understand that it has product of two functions. One is exponential function, and the other is trigonometric function. Now I have to decide the proper order for this. So the proper order, as you all know, we follow Liat. So Liate. Now I noticed that according to the Liat rule, trigonometric function is given higher priority over exponential function. Trigonometric function has higher priority over exponential. So it should be trigonometric function before exponential, but here it is not so. So what I will do is I will change the order. And in case if I do not change the order, what will happen? See, if you don't change the order and you apply integration by parts, you will notice that you never get the answer because it becomes then never ending integration problem. So here I have cos 3x into e raised to 2x and dx. Now, so what I will do is, this is my u. I'm going to apply integration by parts, and this one, the first one is u, the second one is v. The first one is u and the second one is v. So what do? I will, as we all know, integration by parts I apply. So I write here integrating by parts, and as we know that when we are integrating by parts, it is the first function, it is the second function, that is v. Okay, this one only gets integrated. The first one is not integrated. First one is once multiplied, and second time the derivative of the first one is multiplied. So what will it be? It will be I equals to cos 3x integral e raised to 2x dx minus big integral, and then I have d by dx of cos 3x integral e raised to 2x dx, the bracket closes, and then dx. So I have therefore I equals to cos 3x integration of e raised to 2x is e raised to 2x upon 2 minus big integral, and here d by dx of cos 3x, derivative of cos 3x is minus sine 3x into derivative of 3x, which is 3, and integration of e raised to 2x is e raised to 2x upon 2 dx. What I do next is I will now so next step I write here I equals to, it is cos 3x into e raised to 2x upon 2 plus this negative sign I take out, negative with negative becomes positive, and this is 3 by 2, a constant I write out 3 by 2, and I have here sine 3x into e raised to 2x dx. And I notice that I'm getting integration of sine 3x into e raised to 2x, and which is once again integration by parts. I'm going to apply integration by parts once again. Okay. This time we will have to be more careful because outside we have got a constant multiplied 3 by 2. So this 3 by 2 will be a constant to be multiplied for everything that you get when you apply the integration by parts. Okay, so I write here integrating by parts. So here I get I equals to I get cos 3x into e raised to 2x upon 2 plus 3 by 2, and then I make a big bracket. Okay, and now everything inside the bracket. So this is, the order is definitely correct. It is ETLIA, sorry, it is TE. Okay, the order is correct. Trigonometry has to be before exponential, as we had done earlier in this part. So here what we have sine 3x. Sine 3x is u, so u integral v dx minus big integral d by dx of u, which is sine 3x, integral v dx e raised to 2x dx, and then once again dx. Now this dx is for this bigger integral. Okay, the bracket gets closed. So I have I equals to, it is cos 3x into e raised to 2x upon 2 plus 3 by 2, and this here I get sine 3x, integral e raised to 2x is e raised to 2x upon 2 minus, then I have integral here d by dx of sine 3x. So this is sine of 3x. So I get here cos 3x into derivative of 3x, which is 3, and integration e raised to 2x is e raised to 2x upon 2. Okay, and here dx. You will have to be a bit careful because you are getting several brackets, you are getting integrals. Okay, so go slow, but then try to get it proper. Next, what I do is this 3 upon 2, which I have outside, I multiply this 3 upon 2 inside with both the terms. Okay, because this 3 upon 2 is causing me write one bracket, so if I multiply 3 upon 2, at least I will get rid of this outer bracket. So here I get I equals to, I get here cos of 3x into e raised to 2x upon 2 plus this will become 3 upon 4, 3 upon 4 sine 3x into e raised to 2x. Okay, and then 3 upon 2 here when multiplies this term. Now, what you notice here is that already we are going to get 3 upon 2 outside for this integral. This 3 and 2, this 3 upon 2 will, this 3 upon 2 will come outside here. Okay, outside the integration, and this 3 upon 2 which will come out when multiplies this 3 upon 2, it will become 9 upon 4. What it will become? It becomes 9 upon 4. Okay, so I get here negative, and definitely negative because this is positive. I get 9 upon 4 and integral cos 3x into e raised to 2x dx. Cos 3x into e raised to 2x dx. And when we get this, then I understand that what I achieved here. See, what am I getting? I'm getting that problem repeated as it is. See, integral cos 3x into e raised to 2x dx was something that we started with. You see this? And what is this equal to? This is I. This is I. You remember we had done a problem of sec cube x, integral sec cube x dx, and cosec cube x dx. There also, the question had repeated itself, the integral had repeated itself. So here I'm going to write I. Okay, so I write here I, write here I, and then this is equal to, let me take e raised to 2x common here. So I take e raised to 2x common. I get cos 3x upon 2 plus 3 upon 4 sine 3x, 3 upon 4 sine 3x minus 9 upon 4 I. I get 9 upon 4 I. Now next step, I shift this. 9 upon 4 onto left hand side. So I get I plus 9 upon 4 times I equals to e raised to 2x and cos 3x over 2 plus 3 upon 4 sine 3x, okay. And then since I don't see any integral sign here, so I can write it here as c dash. Now why I'm writing c dash, you will know within a minute. So the next step is I take I common on the left hand side, and when you take I common you get 1 plus 9 by 4, okay. So I take I common on the left hand side, so I get 1 plus 9 upon 4 times I, 1 plus 9 upon 4 times I equals to e raised to 2x equals to e raised to 2x, and inside the bracket I get cos 3x upon 2 cos of 3x upon 2 plus 3 upon 4 sine 3x plus 3 upon 4 sine 3x plus c dash, okay. Now what I get is I get here LCM as, okay, so here LCM is 4 and I get 4 plus 9, 4 plus 9, that is 13. I get 13 upon 4 times I, and this side e raised to 2x. I take 1 upon 4 common here. 1 upon 4 I take common. So 1 upon 4 when I take common, I get 2 multiplied in numerator, 2 times of cos 3x plus 3 times of sine 3x and plus c dash, okay. Now this 4 cancels this 4 and I divide by 13 throughout. That is, I take this 13 on the right side in the denominator. So which will get me I equals to, I will get e raised to 2x upon 13. And here I get 2 times cos 3x plus 3 times sine 3x plus c dash upon 13. Yeah, because I'm dividing throughout by 13. In the next step, c dash upon 13, I shall be writing c. So I get therefore I equals to e raised to 2x upon 13. And here it is 2 times cos 3x plus 3 times sine 3x plus c, where c equals to c dash upon 13. This is the final answer that we have. I got the final answer here. This is the final answer. That is the solution. We have integrated the given function. So here we have few practice problems. See, second first, you can integrate e raised to 2x into sine 3x dx. So the one that I just integrated, what e raised to 2x into cos 3x dx, and what you have e raised to 2x into sine 3x dx. So we have sine 3x in this question, and the earlier question we had cos 3x. So this goes on same line. You will do exactly what you did there. So the first thing is you will change the order of the functions. You know, sine 3x, it is trigonometric function. It has to be before exponential function. So you will change the order and then you will go ahead. Also very important that when you start solving, you always write it as I, and that's so very useful, because as you saw that when you integrated it, so you had to apply integration by part 2 times, and when you applying integration by parts for the second time, you end up with I itself. Now as you had assumed it to be I, writing I there and then simplifying becomes much easier. So this is what you do here. You can solve this problem, and also e raised to minus x into cos 2x. Okay, this also you will begin by writing I. So these two problems you can definitely practice. These two problems. If you have any doubt, you can always put in the comment section, and I shall be making a separate video for all these doubt problems. So now let's begin with another question, and that question is, so here we have few problems, that is from the main question 1, number 13. We have already solved up to number 12 from the main question 1. So 13, 14, 15, 16, and 18. Now here you have these problems, these all problems are going to use integration by parts. But the thing is, they all are they all are substitution type of problem. Like when you start solving, you will notice that there is a kind of substitution that you have to make use of. So only when you make the use of substitution, the problem will get converted into integration by parts. So all these problems we are going to use integration by parts, but not in the beginning, only after a substitution. Okay, so let's begin with the first question itself. I will begin with the first question, which is log of log x. It is log of log x, and so I write the solution here, 13th. I write here, let I equals to integral log of log x the whole upon x dx. Now students, if you remember uh, earlier problems of integration, maybe few lectures back, we had we have had the concept of bad angle. Like if I have sine of some angle here which is not x, and I'm integrating with respect to x, and definitely, it's not only this, there is something more that I have, but this angle I notice is not x, this is not x. So what do? I call such angle as bad angle, then it is bad angle. Okay, it is bad angle. So here, okay, I can show you that. You can check here. See, you got sine of log x square. What do you have? You have sine of log x square. In this problem, we see this. It is sine of log x square. You do have log x there. You do have x in the denominator. But what is more important, you have sine of log x square, and you are integrating with respect to x. So when we are integrating with respect to x, the best thing that we would like to have is sine of x. We want to have sine of x. That is what something we will like to have. Like here, this is theta, and here we have sine of theta. So this angle is not bad angle, it's a good angle. Okay, but then this one is a bad angle. Why? Because I'm integrating with respect to x, so I would like to have cos of x, but this is not x, this is something other than x. So remember students, whenever we have some angle which is not x, it is something different. So what we call that as bad angle. And remember, we always put bad angle equals to t. If you don't know this, you should check the videos that I have solved. Okay, so we always put bad angle as t. Now similarly, if you remember, we solve problems and say we have got here, I have got here 5 raised to sine x into cos x and dx. Now what function is this? See, this is constant raised to variable, but then this variable, it's a power, it's a power in this question. In this integral, it's a power, but 5 raised to sine x, once again the same thing, this power I will call it as a bad power. It's a bad power. Why bad power? It's a bad power because I would like to have 5 raised to x. Why should I have 5 raised to sine x? I'm integrating with respect to x, so I would like to have here 5 raised to x. So if I'm not having x, if I'm having something other than x in the power, I call that as bad power. So as we have the concept of bad angle, bad power, look at this. Sine is a function, constant raised to variable, this is a function. So as this, look at this, it is log of log x, it is log of log x. And my dear student, I do not want to have the variable of this log as log x. I do not want to have the variable of this log as log x. As I said that we would like to have, if I'm integrating with respect to x, I would like to have x here. If I'm integrating with respect to x, then the power I want to have is x. Same way, here I'm integrating with respect to x. What I'm integrating with respect to? I'm integrating with respect to x. So if I'm integrating with respect to x, I would like to have log of log x. What I would like to have? I would like to have I would like to have log of x. Okay, excuse me. I would like to have log of x. This log, I would like to have this as x, but what I notice, it is not x. So this is, I call bad variable. As this was a bad angle, it was something other than x. I call this as it was something other than x. Let me write f of x. So as I call this as bad angle, as I call this as bad power. Here I do not have log of x. I want this to be x. So I call this as bad variable. Okay. And remember student, whenever you have bad angle, bad power, bad variable, you always put that as t. What do? You put that as t. That's the key substitution. Always remember that. So here I will write, see, I write here, put log x equals to t. Which log x? This log x, I'm putting it as t. So I write here, put log x equals to t. Put log x equals to t. Now I differentiate with respect to x. I differentiate with respect to x. So what I get, d by dx of log x is 1 upon x. And here I get d by dx of t. Now this dx I multiply here. So I get dx upon x equals to dt. Okay. So see how does this change? So dx upon x, as you all know that after substitution, we are going to write a new integral. We will write a new integral that will be completely in terms of t. So dx upon x, I shall be writing dt. I shall be writing dx upon x as dt. And here I have, see, I equals to, I have log of t, log x is t, so log of t, and dx upon x is dt. Okay, so see what I got. I got log t dt, right? I want to integrate log t dt. What will I do? I will write this as log of t multiplied with 1 and dt. Log t multiplied with 1 dt. And you always know whenever we have whenever we have whenever we have product of functions where one of them is 1, and I want to integrate by parts, I always write 1 as v. So we will apply integration by parts, and this 1, the second factor 1, we will take it as v, and log t is u, so that we will have to integrate 1 only. Okay, so here I write, therefore I write here, therefore integrating by parts. I write here, therefore integrating by parts. So what do I get? I get, therefore I get I equals to log t integral 1t 1 dt. So here I get log of t integral 1 dt minus big integral, and I get here d by dt of log of t integral 1 dt and whole dt. So here I have, therefore I equals to log of t integral 1 is t minus, here d by dt of log t is 1 upon t, and then again t dt. Okay, log d by dt of log t is 1 upon t, and integral 1 dt is t. So now this t and t cancels. I get here t cancelling. So next step I have is, therefore I have it here as t log t, I write t first, and then integral 1 dt. So I get here I equals to t log t minus integral 1 is t plus c. When all the integral signs are over here, that is, we have integrated each and every function, we will add the constant of integration. And what was t? T, we had taken it as a log x. So we write there for log x, t is log x. So I resubstitute log x into log of log x minus log x plus c. This is the final answer that you have. You got the final. This is what you got after integrating. This is the final answer. Okay. So I hope you have followed it, and you can see this once again and practice. Remember, practicing these problems are important. So the best thing that you can do is you see a solution and then try to solve that solution without looking at the solution. Okay, you can just see the solution, try to understand. You can make a note of main points, and then you try solving that on your own. Practicing is important. Now see this question number 16. So this question number 16 is similar to question that we just solved, 13th. Why? Because here we had log of log x, and as I had log of log x, I wanted it to be x. So I call that as bad variable, and I put that bad variable as t. So here you know the same thing. Here I have got log of cos theta. Look at the integrand. What is integrand? Integrand is something that you want to, a function that you want to integrate. This whole function that you are integrating, it is a function of theta, and we are integrating with respect to theta. So that is d theta. Now here what you notice that we got log of cos theta. Now when I'm integrating with respect to theta, I would like to have log of theta. So what I can call this cos theta as a bad variable. So I will write here, put cos theta as t. So what will happen? Cos theta as t, I differentiate with respect to theta. Instead of everything in x, this time you have everything in theta. So I differentiate with respect to theta. I get d by d theta of cos theta, which is minus sine of theta. And here I get d by d theta of t. Now I notice when I see this integral, I notice that here, see, I have got sine theta multiplied to d theta. Sine theta multiplied to d theta. Here I have, see, I have sine theta d theta. Now, as you all know, whenever we are using substitution after derivative, we always see if we have something which we can resubstitute. Okay. So here sine theta d theta. So I get here sine of theta into d theta equals to minus dt. I shift this negative sign here. So the new integral after substitution that you will get, and that will everything be in t. So you will get log of t, as you are writing cos theta as t. So that will become, see, the new integral will become log of t. And for sine theta d theta, you write minus dt. What do you write? You write minus dt. So log t into minus dt, this negative 1 you write out, you write negative 1 out, and log of t dt. And as you know, log of t dt, I will write log of t into 1 dt, and then I apply integration by parts. The same thing you have already done here. See, log t into 1 dt. The only difference here is that you got a negative sign outside, you know. So here, when you integrated, you can check here, you have already integrated log t into 1 dt, but there was no negative sign here. Okay, but this time what you are having, you have a negative sign. So whatever answer that you got after integrating log t into 1, so what had you got? You had got here t. You can check, when you integrated log t into t, you had got here t log t minus t plus t. So here what you will get, when you will go ahead, you will get the reverse of what you got, you know. Here you will get you will get t positive, and you will get t positive, and t log t you will get negative over here. Okay, so I'm sure you can complete this. I have given you enough hint steps. You can complete this on your own, and don't forget to resubstitute t. After you will have integrated, you will have to resubstitute t, and which is cos of theta. Okay, beware of this negative sign. It is negative sign outside. Now let's see this question number 14. 14th question I have copied there. It is t multiplied to sine inverse t divided by root of 1 minus t square. Now what I do here is, once again, I go for substitution. And see, the idea of substitution I get only when I see the function completely, you know. I notice if I put this sine inverse as t, definitely I will have to differentiate. And when I differentiate sine inverse t, what am I going to get? I'm going to get 1 upon root of 1 minus t square. And then this dt will get multiplied with it. And I will get a substitution for dt upon root 1 minus t square. Now, how will that happen? Let me solve it and tell you. So here, you know what, I will put sine inverse sine inverse t as x. Now this whole thing is in t, so the substitution that I do it in x. Normally when we have everything in x, we do the substitution in t. So here I write here, put sine inverse t equals to x. So I write differentiating with respect to t. So d by dt of sine inverse t, I write here, which is 1 upon root of 1 minus t square, and here I get d by dt of x. Now this dt comes in the numerator. I get dt upon root of 1 minus t square equals to dx equals to dx. Okay, so see, as I told you, dt upon root of 1 minus t square, and here we have that. See, here we have that dt upon root of 1 minus t square. Here we have, see, dt upon root of 1 minus t square, dt upon root of 1 minus t square. What will that become? That becomes dx. So when you go for writing the new integral in x, so you will get I equals to, integral. For sine inverse t, we are going to write x, so we will write x, and this dt upon root of 1 minus t square, we are going to write dx. Now the question is, what do I write for t? Okay, so see, when you have written, you cannot write t here because you have written dx. So you will have to write everything in x. So here, see, what do I write? You know, since sine inverse t is x, what is t? T is sine of x. Sine inverse t is x. So t is sine of x. Sine of x. So for t, I write sine x. Okay, so here you get the integral as, okay, I'll do one thing. I'll write this once again. So let's have a repeat. I want to write integral in x. So integral in x, dt upon root of 1 minus t square is dx. Okay, and then sine inverse t is x. So I have written for this, but t is still left. So t has to be written in x. And what is t equals to? T is sine x. You will get the value of t from the substitution that you had made earlier. Sine inverse t, you take it as x. So t is sine of x. T is sine of x, and then you will apply integration by parts. Let's check whether the order is correct. See here, when I go for the order, I understand that this is a trigonometric function. Sin x is trigonometric and this is algebraic. So here I'm getting TA. Okay, let's check whether it is correct order. So it has to be according to Liat, L-I-A-T-E. So as per Liat rule, A has to be before T, A and then T, but here it is not AT, it is TA. So what I will do, I will change the order. So it is I equals to x into sine x and dx. And now you can apply integration by parts. This you will write as, this is algebraic and this is trigonometric. Now the order is correct. This is u and this is v. We are going to take this as u and this as v. And when you apply integration by parts, you know, it's always that v which is integrated, u is not integrated. So you can now complete it. I'm sure you will be able to complete it now. Okay, please complete this. Now we have here 15th question as cos of root x. See this problem I'm solving, 15th integral cos of root x dx. Now in this, what I notice once again that we have cos of root of x. See, the angle for cos is a trigonometric function, and I notice that angle is root of x. So if I'm integrating with respect to x, as I've told you, dx, that is with respect to x. So I would like to have angle of cos as x. I would like to have angle of cos as x. See, if I had something like this, cos x dx. So this is in its most basic fundamental form, cos x dx, and it is sin x plus c. Integration is sin x plus c. So here I can apply the result here, I cannot apply this result here. Why? Because it's not working. It's not working. The result says cos of x with respect to x. Then you write sin x plus c. Integral cos x dx is sin x plus c. But this result is not applicable here because it is not following the law. What's happening? What is it which is not making me apply this definition? it is that root x, because it is cos of root x. So what I understand that this root x is bad angle, I write here. And as you know, if we have bad angle, bad power, bad variable, we put that as t. We put substitute for that. So this is in x, so we will put it as t. So when we had in t, you saw in the previous question, when we had in t, we put that in x. So here I write put root of x equals to t. So when I put root x as t, what is next step? Next step is I differentiate with respect to x, differentiating with respect to x, and d by dx of root x is 1 upon 2 root x, and this is d by dx of t. I get what I get? I get d by dx of t. So the next step I write is, I get here next step as I equals to, I get here I equals to, wait, I need some changes to be made. So next step what I do is, I take this 2 root x in the numerator on the right hand side, and dx I take it here. So see here, dx into 1 is dx, and here I get 2 root x dt, 2 root x dt. But then, you know, with dt, when you are writing root x, it should be written in t. So here see, root x is t. What is root x? Root x is t. Root x is t. So this becomes dx equals to 2t dt. So now everything is ready for us. I'm going to write the new integral in t. So see, for dx, what I shall be writing? For dx, see, this is my old integral. After substitution, I have to write the new integral. So for dx, I shall be writing 2t dt. And for root x, I'm going to write t. So the new integral that we will have is, see here, so I will have therefore I equals to cos of, this is t, cos of t, cos of t, and for dx I write 2t dt. So 2t and dt, right? This 2 I take out, 2 is out, so I get here cos t into t and dt. Okay, now see, this is algebraic, and sorry, this is trigonometric. This is trigonometric function. This is trigonometric function, and this one is algebraic function. T is an algebraic function. So TA is not the proper order. As you saw earlier also, we did this. We will follow Liet. We are following Liet, Liate. So according to Liet, it is A then T, algebraic then trigonometry. So what I will do, I will change this order. So this is 2 times t multiplied to cos t dt, and then I go ahead, I integrate by parts, and I get the proper answer. You can always do this. Take care of this 2 outside. You will have to put a bracket, and see, once you will have integrated, you will substitute what t is. T is root x. So don't forget to write, don't forget to replace that t by root x. Okay. So you can watch this once again, and all these problems which I have solved few steps, and then I'm asking you all to complete it. You should make sure that you write, you understand from the beginning, and then you try solving without looking at, you understand with the beginning, and then you try solving right from the initial step, right from the first step. Don't do only the part which I haven't done. You should write the complete solution. That will make you perfect. Okay, so students, this question where we have sine of log x square upon x, sine of log x square into log x upon x. This is question number 18. And this question, once again, what you notice is you got here sine of log x square. So this log x square is the bad angle. You will substitute log x square as t, and then you differentiate with respect to x. You will get amazingly interesting steps, and you will solve this on your own. Okay, you must try this. You will solve this on your own. Now I take question number 17 from this exercise. post 17, and 17th is let I equals to x multiplied to cos cube x dx. I solve this problem, x multiplied to cos cube x dx, and see, I notice that x is algebraic function a and cos cube x is trigonometric function. So if I'm going by Liet, so it is LIA, it is LIA TE. So as per the Liet rule, A and then T, so it is proper. So if I'm applying integration by parts, see what will happen. If I apply integration by parts, it is cos cube x which will be integrated first. So what I will get is x integration of cos cube x dx minus big integral d by dx of x and integration of cos cube x dx and then dx. So I have to integrate cos cube x, and I know cos cube x cannot be integrated that easily. So what I do here is I will first go for cos cube x. So see, what do I write? For cos cube x, I write, we know that, see here, I write the formula for cos 3x. We know that cos 3x is 4 cos cube x minus 3 cos x. So this gets me cos 3x plus 3 cos x upon 4 is equal to cos cube x. Now once I got this, I will substitute for cos 3x. I will substitute this for cos 3x and I will begin with the integration. So here I get, so I will become, therefore I will become x, and for cos 3x, see x you wrote, for cos 3x you will write this, which is cos 3x plus 3 cos x divided by 4 and dx. Now 1 upon 4 being a constant, I write it out, and here I multiply x inside. So I get x cos 3x plus 3 times x cos x and dx. So this will get me, now I write separate integral, I equals to 1 upon 4 and bracket x into cos 3x dx plus 3 is constant out, integration of x into cos x dx. So this will get me, I write this as I equals to 1 upon 4, and this one I write I1 plus 3 times I2. I write it this way because I understand both of these have to be integrated using integration by parts. I will have to apply, this is my I1, which I will integrate by parts, and this is I2. This is I2, which I will integrate by parts. So I will integrate them separately and then substitute here. This is my 1. This is equation number 1. So I will take I1, solve it, take I2, solve it. For I1, I will add the constant of integration as C1. For I2, I will add the constant of integration as C2. And then I will substitute here. And for C1, C2, later, after multiplying the constants, I will write it as C. We have done enough problem of this type, so you can definitely solve this. Okay, I've given you enough hint for this. The next problem that we have is cos of integral cos of cube root of x dx. This is quite interesting problem. What I notice is once again here I have bad angle. See, this is not cos of x. So what I will do, I will put this bad angle as t. My integrand is this. And in this I notice that cos doesn't have the angle x. So this is my bad angle. So I will put cube root of x equals to t. Now you know cube root is nothing but x raised to 1 by 3 equals to t. I take cube on both sides, so here I will get x equals to t cube. Then I differentiate this with respect to, you can differentiate with respect to x or t either. So I will differentiate with respect to t. I get d by dt of x equals to d by dt of t cube. So here you get dx by dt equals to d by dt of t cube is 3t square. You get 3t square. Now you write the new integral that will be in terms of t completely. So I equals to, you get cos of t, and for dx you will write, what is dx? Dx is equal to 3t square dt. So here you write 3t square and dt. Now this 3 is a constant multiplied, so 3 can be taken out, and you have cos t into t square dt. So this is trigonometric and this is algebraic. Liate. It has to be a then t. So what I will do, I will have to change the order. So I write here I equals to 3 times t square into cos t and dt. So this is t square. The power of algebraic function is 2. So I will integrate this. This is for the first time we are getting it this way. See, earlier we have got trigonometric into algebraic, but there the power of x was 1 only. Here also the power of x is 1. For the first time we are getting the power of x, the power of algebraic as 2. So I will do it for you. So here I write integrating by parts. I get I equals to 3 times t square integral cos t dt minus big integral d by dt of t square integral cos t dt and then again dt. So here I get I equals to 3 times t square into sine t minus big integral d by dt of t square is 2t, and then this is sine of t dt, cos t dt sine t, and then this final dt. The bracket closes. I equals to, I get 3 times t square into sine t minus this 2 is out. 2 is out, and I have integral t into sine t dt. So you understand, when the power of algebraic is t square, you are supposed to apply integration by parts once more. So when you apply integration by parts once more, what you get is so here you had I equals to 3 times, you had I equals to 3 times t square sine t minus 2, and then inside the bracket t square sine t minus 2, inside the bracket you have t sine t dt. So that is, you will put another bracket, because you know when you apply integration by parts, when you will apply integration by parts for this, you will get 2 terms. So you put a bracket and you write t integral sine t dt minus big integral d by dt of t integral sine t dt. The bracket closes, dt, again the bracket closes, and then final bracket. Okay, so let me use another color for this to make you understand. See, this bracket is for 2. Outside we have this 2, so here it is, this bracket is for 2, and this bracket is for bigger integral. Okay, now I hope it's clear to you, the uses of bracket. And then this final bracket is for 3. I have therefore I equals to, let me multiply this 3 inside now. So it will relieve me from the outer bracket, 3t squared sine t minus 6, 3 into 2 is 6, and then I have this bracket. It is t, integration of sine t is minus cos t minus big integral. I have derivative of t is 1, derivative of t with respect to t is 1, and this is minus cos t and dt, the bracket closes. So here I have I equals to 3t square sine t minus 6 and minus t cos t plus integral cos t dt. So here I get I equals to 3t squared sine t. Now multiply the 6 inside, so plus 6t cos t minus 6, and integration of cos t is sine t plus c. All integration sign have been evaluated, so you will add the constant of integration as c. Now what was t? T was, if you remember, t was cube root of x, that is x raised to 1 by 3. So I equals 3 x raised to 1 by 3. So this will become x raised to 2 by 3 sine of cube root of x plus 6 cube root of x cos of cube root of x minus 6 sine of cube root of x plus c. This is the final answer. This is the final answer here. We have completed this. This is the end of the lecture number 19. Thank you very much. Practice these problems again and again.